Good morning. We are now going to start our unit on quadratics. The very first learning target that we are going to work on is our ability to solve quadratics. Before we start solving the problem that I have here, let me just give you a little bit of background information about quadratics. So a quadratic is basically a trinomial where one of your terms is being squared. Okay, that's actually where the term quadratic comes from, the fact that the term is being squared. You're going to see this happen a lot, actually. It's not going to only be in this unit. You're going to start to see it in other units as well as other higher level math classes. So these skills I'm about to teach you are actually extremely important because you will be required to know them in the future. So when we are solving a problem, we are actually looking for the solution. Okay? I'll give you a little information about this in a second here. And when I'm solving a quadratic, I actually need to get my equation set equal to 0. So as of right now, my equation stands as 7v squared minus 42 equals negative 35v. It is not equal to 0, so what I need to do is add 35v to both sides. And when I add it onto the left-hand side, I'm actually going to put it in order from terms of their exponents. So now I have 7v squared plus 35v minus 42. If you notice, I got this at equal to 0. Another term for a solution is actually a 0. I'm also solving for a 0. The letter v, the variable that would make this equation equal to 0. All right, my first method that I'm going to be doing is factoring. So I like to kidnap when I factor. So I now have v squared plus 35v minus, 42 times 7, that's 294. I know, big number here. So now I create my factors. And now I got to ask myself, what multiplies to be negative 294 but adds to be positive 35? Well, that answer would be 42 and 7. And we're going to have a positive 42 and a negative 7. Because we want to have a positive 35 and a negative 294. Well, we kidnapped that 7 in the first place, and now we got to put him back. So now I put him back inside my parentheses next to my v, and I check for the greatest common factor in both of my sets of parentheses. My first set of parentheses, I'm noticing, okay, I don't have actually any GCF. So that's going to stay the same, 7v plus 42. Now, in my second set of parentheses, I'm noticing that I have both a 7v and a negative 7. Well, 7 goes into both of those numbers, so that means I can pull out the 7, and I'm left with v minus 1. Now, in my kidnapping method, that's an imposter, and I don't like fake people in my life, so I erase him. So now I have completely factored this expression. The last thing I need to recognize is the fact that this whole thing was set equal to 0. Now, I can set both of my factors equal to 0, because if either one of them equals 0, 0 times a number is always equal to 0. That is why I have to set both of my parentheses equal to 0 to solve this expression here, because at either time, these two values would make this equal to 0. So here we go. First guy, we subtract 42 on both sides. Let's just do this. 7v equals negative 42. And we divide by 7. So v is equal to negative 6. Then over here, we have v is equal to 1. v is equal to 1 and v is equal to negative 6. What these two numbers represent, negative 6 and 1, they are my solutions. They are my zeros. Where they actually also appear, they are appearing inside my factors. Where you're also going to see them appear, actually, when we start to graph, they're going to become your x-intercepts. And what essentially these are of your quadratic, they are your roots. All of these concepts essentially mean the same thing. For this quadratic, negative 6 and 1 are both the x-intercepts, the roots, the zeros, the factors, the solutions. I think I said them all. So this is solving a quadratic by factoring. Always remember to set it equal to 0.